Hello, today we are going to discuss another part of the differentiation. We are going to find the derivative of the trigonometric functions and the inverse function, arc sine and arc cosine and all this type of function. And then we discuss about the implicit differentiation, and this will be a lot of interesting topics in that. Okay, I hope you enjoy this session. Okay, I'm going to start with finding the limit of theta goes to 0, sine theta divided by theta. Look at this diagram here. You can see that AB is r sine theta. Therefore, AB is equal to r sine theta. And theta is this arc AC. Arc AC is equal to r theta, therefore arc AC is equal to r theta. Therefore, limit theta goes to 0, sine theta divided by theta is same as limit theta goes to 0, AB divided by AC. You can see that as theta goes to 0, the length of AB and AC approaches to each other. Therefore, the ratio of them will be equal to 1. Therefore, this is a very important fact. It was not a mathematical proof actually, but it will help you to remember that. But mathematical proof is actually using this idea and using that sandwich theorem, and then they can prove this one. But the idea is the exactly same thing. Now let us see. The one fact we got is that limit theta goes to 0, sine theta divided by theta is equal to 1. This is a very important factor in finding derivative of sine and cosine. The next one I'm trying to show you is limit theta goes to 0, 1 minus cos theta divided by theta. I'm trying to find the value of this. For this, I will multiply numerator and denominator by 1 plus cos theta. So this will be equal to, numerator will be equal to 1 minus cos square, which is sine square theta. Therefore, this is equal to limit theta goes to 0, sine square theta divided by theta times 1 over 1 plus cos theta. We can see that this is equal to limit theta goes to 0. I can write this one sine theta divided by theta times sine theta times 1 divided by 1 plus cos theta. This will be equal to, we can see that limit of this we have already proved is 1, and this one is 0, and this one will be 1 divided by cos 0 approaches to 1, therefore this will be 1 over 2. So the answer is 0. Another fact we have shown is limit theta goes to 0, 1 minus cos theta divided by theta is equal to 0. Using these two facts, we can find the derivative of sine and cosine. Let us start by derivative of sine. Y is equal to, or y equal to f of x, equal to sine theta. Oh, sorry, sine x. F of x equal to sine x. Now we know that dy by dx is equal to limit delta x goes to 0, sine x plus delta x minus sine x divided by delta x, which is equal to, I can expand this, sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Therefore, this will be limit delta x goes to 0, sine x cos delta x plus sine delta x cos x minus sine x divided by delta x. From the first term and the last term here, this term here and this term here, you can see that sine theta is common. I can factorize sine theta there. Then let's see what I'm going to get. Therefore here limit delta x goes to 0. I will factorize sine x. I am going to get cos delta x minus 1 I plus sine delta x cos x divided by delta x. Okay, now we can see that I can split this to two limits. Limit delta x goes to 0. Here I can say this is sine x times cos delta x minus 1 divided by delta x plus sine delta x cos x divided by delta x. We have already proved 1 minus cos theta divided by theta, or doesn't matter, this is a negative sign, but the negative sign doesn't change the limit with negative 0, which is same. So this part we have already proved this is 0. Therefore this goes to 0. We have proved this one. Therefore this part will be 0 times sine x. Therefore this will be equal to sine x times 0. And this part we know that we have already proved sine of an angle divided by angle when the angle goes to 0 is 1. Therefore we know that this is 1. Therefore that is plus 1 times cos x. So which is equal to cos x. Okay, now let me go exactly same method. You can find, for now we have already defined if y is equal to sine x, dy by dx is equal to cos x. Therefore this is already proven. If you have got y equal to cos x, exactly with the same method, you can write it in this format, expand it, and using these two limits which I have already discussed, then you are going to get it dy by dx is equal to negative sine x. That part I will put for you. You can try it. If you cannot do or you have any difficulties, you can just put a message for me. I will help you on that also. Okay. Now let's go for the inverse function. Before discussing about the derivative of the inverse function, I am going to discuss a little about the inverse function itself, inverse of trigonometric function, sine inverse and cos inverse, or arc sine and arc cos. Okay, let's see if y is equal to sine inverse of x, which you have seen on your calculator, or arc sine x, arc sine x. These two are exactly the same thing. Before discussing this, I want you to note that sine x is not a one-to-one function, so this does not have an inverse. Then what we are trying to do is this. You see, look at this function. This is the function sine x. Okay, now you can see that it is not one-to-one, it continues to infinity from both sides, and you can see that it is not a continuous function. But if you restrict the domain of the function from negative pi over 2 to pi over 2, this function sine x, this is sine x, it will be an it will be a one-to-one function. Therefore, I will consider the graph of the function sine x is from negative pi over 2 to pi over 2. So it starts from here to there. Therefore, now I say if f of x is equal to sine x with x between pi over 2 and negative pi over 2, and y will be between 1 and negative 1, which is clear, always it is between 1 and 1, we know that about the sign. F inverse of x, which is arc sine of x, then in that case, x is between 1 and negative 1, and y is between pi over 2 and negative pi over 2. Okay. This we are using this fact, and we are doing this. And what is the meaning of that? Y is equal to arc sine x. Y equal to arc sine x. This means sine x sine y is equal to x. Now I can differentiate x with respect to y. Then I can say dx by dy is equal to cos y, which it gives us dy by dx equal to 1 over cos y. Okay, now I know that sine y is equal to x. Here I have this equation sine y equal to x, and I know that sine square of y plus cos square of y is equal to 1. Therefore, cos y will be equal to plus or minus square root of 1 minus sine square of y. Okay, now sine square of y is x, therefore this is plus or minus 1 minus x squared. But note that y is between negative pi over 2 till pi over 2. That means it is in the fourth quadrant or first quadrant. Cos is always positive. Therefore, this negative is not accepted anymore. Therefore, cos y is equal to square root of 1 minus x squared. Okay, therefore, now I have got the dy by dx. Now you can see if y is equal to arc sine x, then dy by dx is equal to 1 divided by square root of 1 minus x squared. Exactly the same method, you can go for y equal to arc cos x. I will write the domain of this function, and then domain of this function x is between pi and 0. In that range, cos is 1 to 1, you can define this, and y is between 1 and negative 1. So, and dy by dx in this case, dy by dx will be negative 1 divided by square root of 1 minus x squared. Okay, now remember the chain rule. Now you can differentiate any function of arc sine and arc cosine and sine and cosine. So easily you can differentiate the function. Let me give an example, some example like that. Suppose y is suppose y is equal to arc sine of x plus 1 divided by 2x minus 1. Now you want to differentiate this. if you want to differentiate this, dy by dx. Okay, you know that this is dy by du times du by dx. Considering this as your u, therefore this is your u. So this will be equal to 1 divided by a square root of 1 minus u square. U is x plus 1 divided by 2x minus 1 square. Now times, this is dy by du. 1 divided by a square root of 1 minus u square times du by dx. Now I have to take du by dx. Du by dx is derivative of numerator is 1. 1 times 2x minus 1 minus 2x minus 2 divided by 2x minus 1 square. Then this 2x cancels, and you can simplify this in the denominator also if you want. Oh, sorry. You can see that this 2x minus 1 to the power of 2, you can write it in this format. 2x minus 1 actually should be absolute value. It comes out of this. To simplify yourself, the algebra part I'm not going to do for you. I hope you can do it. The square root of 3x times x minus 2. And this will be negative 3 2x minus 1 square, which this can cancel this, therefore 1 will remain here. Therefore you are having negative 3 divided by absolute value of 2x minus 1 times the square root of 3x times x minus 2. That is the simplest form you can look at this. Remember that this 2x minus 1 actually was under the second root to power of 2. Therefore, this cannot be negative. This is also positive. This also is positive. Therefore, whole of this in differentiation is negative. If you don't put absolute value here, you think this is some part is less than 1 over 2 is negative, more than 1 over 2 is positive. Therefore, you think your function is not an increasing function, but this function is an increasing function. Okay, let us discuss about the derivative of tan x and other functions related to trigonometric function. Tan x, you can easily write this one as a sin x divided by cos x. Now you can say dy by dx, you can use quotient rule now. Therefore, derivative of sin x in numerator, therefore this one you are differentiating first. Numerator, derivative of sin x is cos x, therefore this will be cos x times cos x. It will be cos square of x minus, derivative of denominator is minus sin x, times this will be minus sin square of x, then divided by cos square of x. You can see that this will be positive, therefore cos square plus sin square. Cos square plus sin square is equal to 1. Therefore, you can write it 1 divided by cos square of x, which you can say it is sec square of x. There is another format of this. We can write this one divided by this one is 1. This is plus this one divided by this one tan square of x. Therefore, all of these three formats are different way of writing it. Therefore, dy by dx, you can write any of these format. Therefore, you know how to differentiate tan x. Now, you may have another thing which is very common, y equal to sec or cosec x, these two. What is the meaning of that? This is another format of writing 1 over cos x, therefore this is y is equal to, this is exactly the same thing to say, y is equal to cos x. No, 1 over cos x. 1 over cos x. Okay, how to find dy by dx? You can write to power of -1 and do the chain rule, or you can directly do this quotient rule. Derivative of 1 is 0, therefore derivative of 1 is 0. 0 times cos will be 0. 0 minus derivative of cos is negative sine, therefore there will be negative sine x, divided by cos square of x. Therefore the answer is sine x divided by cos square of x. Therefore dy by dx is this. Now this you can write different format. You can write sine divided by cos, which is tan x. 1 cos in the denominator will remain, which is sec x. Therefore tan x sec x is another format of writing this. Anyway, or yeah, that is different way of writing the same thing. Exactly for this, you can go for cosec, that is 1 over sine x, exactly same method you can do that. You are getting cot x, cos x, and then you can do that by yourself as a practice. So these are the derivative of this trigonometric function and their inverse. Now, I give one more example of this. Suppose y is equal to arc sine of ln of x. Okay, dy by dx will be equal to, first of all, 1 divided by a square root of 1 minus u squared, which is ln of x squared, times, now derivative of ln of x is 1 over x. Therefore, this is derivative of this function. Okay, thank you for watching. We will continue this discussion in the next section.